over there.
I think, yeah, it's podcast.
Okay. I guess we can get started.
Maybe one minute.
Why 1 minute?
Only these people will come. More people.
There's more people in the class, but since their attendance isn't required and it's podcasted, I'm guessing not many more people will come.
And like, I hope this is not going to be a podcast.
It's fine.
Yeah, this is 133 on the day.
Yeah. Well, I mean, hopefully then we can actually help people if we don't.
This is the.
Yeah, I was so shocked. He was saying so
Do
casual.
we get started?
I was like, wow.
Okay.
So, hello everyone. Hi, so this is the first discussion class for 133, right? So we'll probably be discussing a few questions from what has been taught in the previous class. And if you have any questions what has been taught during the class, in the lecture, you can ask those questions also. And in the discussion sessions close to the exams or the quizzes, we'll be discussing questions which might be helpful for the quiz in that way. Or if you have like questions from the portion that's being taught before the entire session of the quiz. So you are like free to ask questions that have been taught in the lecture, or we'll discuss a few questions which are like very similar to what has been taught in the class.
So most of the questions will be either similar-ish to the homework, similar to the lecture, or similar to the quizzes. We should probably introduce ourselves. So I'm Mahesh. I'm going to be one of the TAs, and then
I'm Abhi. So yeah, we are the two TAs for this course. And I think like you all can, I'm not sure if Dr. Mali like told this, you can like message on Canvas if you have any doubts or regarding any problem or anything. It's the easiest way to like contact us.
yeah, we'll check it pretty regularly, so it should be pretty easy to get in touch with us. And especially kind of once the homeworks are out or the projects are out, I'm sure there'll be more questions that will come up. So if you want to send questions on Canvas, you can do that, or you can bring the questions in to the discussion section. And we will prepare material, but if you have questions, obviously those will kind of take precedence so that we can be as relevant to you as possible. Any questions about the class or anything like that before we get started? No? Pretty straightforward? Okay.
So we'll be kind of trying to discuss like around 6 questions today from what has been taught, and let's see how it goes in terms of the time. So I think we studied regarding the limits. So the first question that we are going to do is, so the first question is, question 1 is to find the limit as x tends to 2, x squared minus 4, and x minus 2. So any ideas like how we can proceed for this question? Like what would be the limit be for this thing as x tends to 2? Yeah.
Factor the numerator?
Correct. So what we do is basically write limit x tends to 2, and this becomes x plus 2, x minus 2, x minus 2. X minus 2 gets cancelled in the numerator and denominator. We plug in this 2 here, so what it becomes is basically 4. So it's a pretty straightforward question, but a very basic question to start with for limits. So is the next question. So let's go to the second question. So the second question is like, so there is a function fx which is basically 1 by x, and we need to find out if this function is continuous at x equals to 1. So is the function continuous at x equals to 1. So can you tell like what's the, like how do we proceed to check the continuity of a function at any point? Like what are the like requirements you need to satisfy to tell like if a function is continuous at any point?
Does f of 1 exist?
Yes. And anything else?
Check if the limit equals the value of the function.
Sorry?
You check if the limit at that point equals the value of the function.
Exactly, yeah. So two things. One is like it has to exist at that point, and also if the limit is like equal to the value of the function at that point. So what we do is like, so the first solution we do as limit x tends to 1. What is the value of this function? We're just basically plugging in 1. So this becomes 1. And the function, the value of the function at 1 is also basically 1. So since like, if we can say like the limit x tends to 1, the value of the function is equals to the value of the function at 1. So we can say like the function is continuous. So this basically implies that the function is continuous at 1 at x equals to 1. So this is basically applying the limits that we learned, like what's the physical understanding of finding the limit of a function. So to find the continuity of a function, we can use the limit and check if the value of the limit at that point and also the value of the function at that point is same. So we can comment like the function is continuous at that point. Do you have any questions from this? Third question. Okay. Third is also pretty similar to the first question, which is again we need to find out the limit. So the third question says like find the limit as x which is minus 1. Okay. So the limit as x approaches minus 1, the function is 2x squared minus 5x plus 1, 2x squared minus 5x plus 1, and x squared plus x minus 2, x squared plus x minus 2. Yeah. So what will be the value of the limit? So any idea how to do this question? Very similar to the first question.
Does that have something to do with dividing the coefficients of the highest powers for them?
Dividing?
X squared, the 2 over 1, so it's like 2. I
Oh.
forgot what the rule for that is. I don't know if there's like a law for that or something.
So are you telling like we divide both by some 2 or something? Or like divide?
Just the coefficients in front of the like x squared. Like
Okay.
on top of the bottom.
But see, the problem with these problem or the first problem was when we plug in the value, we get a 0 in the denominator, which is kind of, you can't solve after that.
Does L'Hopital's rule work?
What?
L'Hopital's rule?
So basically, because the x squareds are the highest power, then that's all that behavior is what becomes most important. But I think that's only if it's going to infinity, right?
Yeah.
Yes.
So I don't think that, I'm not sure if that applies in this case.
Yes.
You just plug in -1.
Yeah, if you plug in -1, what happens? Like this becomes 1,
Yeah, we can
plus
zero.
1 minus 2
How
is
many
basically
zeros?
0. So this turns out to be 0.
It's not really
Wait, no, that,
No,
that's not
no.
true.
Oh, I know what this is.
Because it's 1 and
It's
then minus
1
1
minus 1 minus
2.
So it's -2 at the
No, but if you
denominator.
factor it,
Oh yes. have I written it correctly? X squared plus x minus 2. Yeah.
Was it supposed to be x goes to positive 1?
And if you
Yeah.
factor, it'll be x plus 1 times x.
That would be correct, yeah. Now how would you do it? Because that was the easy question. So basically this discussion session is about learning, so you can like change the questions and
Solve for
till
it.
the point we learn like how to
No,
do
no, no,
this question.
there's no 0.
To get them
Yeah.
this is 2.
You can.
Oh, that. I think. That's good.
Yeah.
Feedback from the
Well, good thing we slowed down now.
So?
It's a good thing we had to slow down
I
now.
don't supply
Yeah,
it.
you're definitely, definitely going fast.
Very
No,
fast.
this doesn't have to go.
Keep doing some more questions.
Yeah, I mean, I can had a couple more. This is probably gonna take you a bit.
Yeah, I'll take one more question.
You have 2 more.
Two more? Oh, yeah, 2 more. Sorry. Any idea people wants?
You can't find.
This one you can.
Then 5 should be a 3.
Huh?
The 5 should
Exactly, that's what I figured out right.
You can't.
That doesn't change the question.
Oh, maybe now you can.
Still the problem is
Is this supposed to be a positive one, the limit? Or
Is it
the
negative?
limit, the final limit, value?
no, like as x
Yeah.
tends to?
I think, wait. Yeah, this is the correct thing right now.
Okay, yeah.
Okay.
See, the factor it.
The problem is always with the denominator, when you plug in this value, it turns out 0. That's the same thing we were having here.
Yeah.
So you plug into it, becomes 0. What to do next?
Okay, so you can just factor it.
Yeah, so you can factor it.
Exactly. Just factor it out. Okay. You did it in the first question. X tends to 1. So what does this mean? X minus 1. X squared, 3x, 1. Right? This becomes
Oh, did you-
x.
You factor it. Now it's the.
Right. 2x minus x is x, yeah. So you factor out like the numerator and the denominator, factorize the numerator and denominator.
Yeah, you just test this.
So the term that was creating the problem, that this 1 plugging in 1 becoming 0, that gets cancelled out. So now you are left with a nice limit where you can just plug in the value. So 2x minus 1 by x plus 2. So this becomes 1, so 1, and this is 3. 1 third. So. Yeah.
This is probably a dumb question, but can you
Yeah.
show how you factored the top
Sure,
part?
sure, sure. So see, since it's a like quadratic thing, so I'll just show this. 2x squared minus 3x plus 1. So suppose like this is a function, consider this as a function. So if you like try to find out what are the roots of this function, so you like plug in, say you plug in 1, you just plug in 1 and you see like this becomes 0, right? So what this, like it's just a function, so f of x is equal to this thing. So what is f of 1? is basically 2 into 1 squared minus 3 into 1 plus 1, right? So what does this turn to be 0, right? So 1 is definitely a root of this function. So if it's a root, so we can definitely write like this. So any function, say if a function x is f of x, this can be written as x minus a. If this is a quadratic function, say, we assume that it's a quadratic function. I think everybody can see here, right? So if it's a quadratic function, we can write it as x minus a into x minus b, where a and b are the roots of basically fx. Right. So once you find out like one of the roots, which is 1, by roots I mean like when we plug in that value, it becomes 0. So when we plug in 1, it becomes 0. So 1 is definitely a root of this function. So we can write it in that way, in this format, where we first write fx, which is basically 2x squared minus 3x plus 1 is equals to x minus 1, because this shows like it's a root 1. So now we kind of try to find out the rest of this term. So we see we have like 2x squared, right? I have written x. So what x like should we write? Like what should the coefficient of x so that we get 2x squared? We have an x here, so if we write like 2x, I did something wrong there.
Yeah, isn't it 2x minus 2x?
Oh no, it's correct. So we found out like 1 is a root, right? So to get 2x squared, we need a 2x, right? So this gives like 2x squared. Now what we have? We have like minus 2x we have, right? Multiplying these two terms. So basically there will be something, plus or minus of something, right, here, which we are trying to figure out. So to figure out, what we do is like we find this term, this 2x squared, we get this term 2x squared. We multiply these two terms, which is minus 2x, right? And we need a minus 3x. So we need like one more minus x, correct? So to get one more minus x, if we have, so this multiplies with this thing, right? So if we have an x of like one more minus x, we multiply this with this, and this goes with this. And then we'll get the x term, right? Because this is a number, so number and x. So we got minus 2x, so if we have like 1, let's erase this, and a minus, so that gives like a minus 3x. See, this multiplied by this is minus 2x, and this multiplied by this is a minus x, which basically is minus 3x. Now the last term like comes like automatically, which is like plus 1, and you see like minus 1 into minus 1 is plus 1. So the first idea is to find at least one root of the function. Immediately once we find the root of a function and we find out like it's a quadratic equation, we can immediately write like x minus 1 or x minus the root. Once we write that, we find out like one term at a time so that it matches the original quadratic equation. So that is how like we did it. Since we had the factors, so we could like easily do that. Like we knew what the factors are. Otherwise, so if we do this thing, x squared plus x minus 2, I can probably do that somewhere.
Maybe you should erase.
So if I do the same thing for the numerator, x squared plus x minus 2. So see, we plug in 1. What happens? Like 1 plus 1 is 2 minus 2. So 1 is a factor. So immediately what we write is x minus 1. So we get one factor. The next thing is we need to get an x squared. So the next term will be some x plus or minus something. And then there might be a coefficient here, which we need to figure out. So I'll write a dash. So we see like these two terms multiply and we get the x squared term. The x squared doesn't have any coefficient. So we are sure like it doesn't have anything as a coefficient. We get the x squared term. The next thing what we see is like we get a minus x, but we need a plus x in the left hand side. So what we need to do is have a plus 2x so that we get a plus x. To get a plus 2x, what we need to do is do a plus 2 so that we get a 2x here, and this is minus x, so that gives like plus x. And the last term like just comes, minus 1 into 2 is minus 2. So the more you practice, you will like get a hang of this. Any more questions you can ask? You can question. Okay. So, yeah, we can probably discuss one more problem. Which one should I discuss? The fourth one or the fifth one? Fourth one, maybe. Fine.
I think
Fifth one?
fifth one is more similar to the home one.
Fifth one is okay. So, another question which I'm going to discuss is, maybe I can lock this. So we need to find the maxima and minima of a function.
It's probably a little hard to see over there because this thing's in the way.
Huh?
It might be a little bit hard. Can y'all see all the way over here?
Yes.
Yeah.
Okay.
Oh, okay.
Just kidding though. Okay. Go for it.
So, since it's a long solution, that's right. So we have a function. So let me quickly go through what. So suppose we have a function fx. I'll just quickly discuss the theory a little bit. So fx, we have a function. Suppose this is the function. Here's the y-axis. Here's the x-axis. And suppose the function goes something like this. So the question is to find the maxima and the minima. So you know, like suppose this goes this way, and you know, like this goes like somewhere here. And suppose so. So for this function, say suppose it is defined by f of x that I wrote here. So the maxima will be this point where the function reaches the maxima, and the minima is this point where the function has the least value of y, the minima and the maxima. So if you see this question, so suppose you get a function, any random function fx, and you are asked to find the maxima and minima of the function. How do you think like we should proceed so that we can find like this x value, say x2, and say this value is x1. How do you find out x1 and x2, and also figure out like is it a maxima or a minima at x1 and x2? Like, yeah.
We could use the extreme value theorem and take the derivative of the function and set it equal to 0.
Okay.
And then we can also plug in, if we have given interval, we can plug in those points. And then I think we can analyze the positive or negative values just to see if it's max or min.
Yeah. You want to add something? Okay. So you know, like these 2 points will have a derivative of 0 because it's a straight line. So the f dash of x2 here will be 0, and here f dash of x1 will be 0, correct? Now once we know like the first derivative of any function is 0, we know like there is either a maximum or a minima there. The next thing is to find out is like if it's a maxima or a minima. To do that, there are 2 ways. The easiest way is to find the double derivative of the function. Sorry for that. Yeah. So if the double derivative of that function at say x1 or any x is basically negative, then it refers to a maxima at that point. And if the double derivative is positive, it refers to a minimum. So maxima, or it's also sometimes called as, it's like concave like downwards, it's called concave downwards, which is basically the graph at that point is the concave is on the downward side, and vice versa for greater than 0, the minima. So we'll quickly do a problem, like in 3 minutes probably.
You can take a little bit extra time. I don't have as many problems today.
Okay. So the function here is f of x is equals to 2x cubed plus x squared minus x. So x cubed plus x squared minus x minus x plus minus 10. I think, you know, check with the values. I think the values will be correct only. So the first task is to also we need to check. So see, we need to check within an interval, because otherwise like it becomes like an infinite function. We don't know like which point or the which domain we are talking about. So we need to check between the domain -5 to 5, that is like x from -5 to 5, like where are the maxima points, where are the minima points. So for this type of problems, the first thing we need to do is to check at the extreme points. That is, say this is -5, say suppose this is an example function. It will have 3, so it will have 2 curves, 1, 2. It will not look like this function will look something different. Say suppose this is -5 and say this is 5. So what the question asks is, if we plot this function, where are the maxima and the minima points within this interval, and also are those we have to find the minima and the maxima points. So the first step is to check at the extreme values of the function and also find the critical values. By critical values I mean the places where f dash x is equals to 0. So to start with, we first do f dash x, which is basically 6x squared plus 2x minus 1, correct? Why did you do
You wrote it wrong in the notes, just keep on going. You get it correct here.
I don't know the value. Okay. So this is the f dash x value, right? So f dash x is 0. So what I said is, when we equate this f dash x equals to 0, at those points we get these critical points, what we're talking about. So equate this to 0. So we do basically f dash x equals to 0. So what do we get? Basically 6x squared plus 2x minus 1 is equals to 0. Right? So we plug in 1, 6 plus 2.
Just do the quadratic formula.
Yeah, just use the quadratic formula. You can't
Yeah.
factor it.
So
How?
So the roots will be, x will be equals to minus b plus minus b square. So basically we write it that way. B square minus 4 into a into c. I hope everybody knows this rules, right? This is Acharya's formula, yeah.
Doesn't 3x plus 2 times 2x minus 1 work?
Sorry?
3x plus 2 times 2x minus 1?
2x minus 1
Yeah.
works 6x
Oh,
squared
no, that's right.
minus.
I was thinking 6x squared. Isn't it factoring the derivative? Or am I in the wrong spot?
I think this term we are not getting, the last term.
Yeah, I just said
It's a
that.
minus 2 and we have minus 1. Yeah. I think the roots will be not like simple roots, we'll have some
It'll be
under
3x plus 1 times 2x minus 1, I think.
2x plus 1,
2x minus 1?
but then it's 4x, right? We have 6x.
Oh, did I write? Oh, whoops, my bad. Sorry. No, keep on going.
So by this, so this is the basic, I think everybody knows this, right? Minus b plus minus b square minus 4ac.
Can you write it out? I just forgot.
Sure. Sure, definitely. Yeah, if you don't know anything, just feel free to ask.
There's also divided by 2a, right?
Yeah. So if we have a quadratic function which is basically ax squared plus bx plus c, and we are asked to find the roots of the function. So the roots, that is x1 and x2, because since it's a quadratic we'll have two roots, is basically minus b plus minus b square minus 4 into a into c divided by 2a. So I just did this. So the plus gives one of the roots, the minus gives the other root.
Yeah, I just forgot the formula.
Yeah, no problem. So let's solve this. What it comes, let's see.
Might be a little bit too difficult to do this by hand.
Yeah.
You're allowed to use calculators on the exam, so if anything like this comes up,
Yeah.
which it shouldn't, because we'll hopefully put in more effort to designing the problems.
Yeah. The numbers will be easy so that you don't have to spend too much time in the calculation. Till the point you understand the concept, you'll be able to do the calculations. So, okay, let's try. So what does this give? Plus 24 and here is a 4, 28. So minus 2, 28, so
2 root 7.
can't cancel also, right? That's okay. Let's proceed. Plus minus root 28 I did correct, right? 6 4 is 24, so plus 4 and 4, yeah. And yeah, it's a 12. So this is the function. So we are sure right now, like, so one of the roots, so this tells like, one of the roots is like -2 minus root 28 by 12, and the other root is -2 plus root 28 by 12. Can anyone do this calculation and tell me the approximate value of what this comes? Like this thing and this thing? Sorry.
It'll be like a fourth.
I just have a logistical question. What kind of calculators does he like allow? So I know some classes are only like the single line ones. Like, are we allowed to use like?
I think he said in the announcements it was any calculators you want.
Okay.
Let me double check, and we can ask him as well.
Okay.
Yeah.
Before the quiz comes up.
Anybody get the value? Did I do something wrong here?
No, I don't think so.
Any, like, somebody tell the value, approximate value.
1/4 for the bottom one.
1.2?
1/4.
Oh,
And then, like negative, like 7/12.
so approximately like 7/12, what does it come like? 0.487.
Like
0.6. 7/12 you said, yeah?
yeah, approximately.
So that's okay. So how this function, so this function has two roots. What this means is now we know these values of x1 and x2. One which is in the negative side, that is -7/12, and the other one that is 1/4 is on the positive side. The next task is to find out if this is a maxima point or a minima point, right? So I said to find out that, what we do is do the double derivative and see if at those points, at those x's, so these are basically point x1 on the negative side and this is x2. So the next task will be to find the f double dash x, which is the double derivative, at x1 and see like if it's greater than or less than 0, and at x2 greater than or less than 0. So we found out like f dash x, let's double derivative this, so this becomes like 12x plus 2. So f double dash x is 12x plus 2, correct? So 12x plus 2, we plug in the values of x1 and x2. So f double dash of -7/12 comes out to be, oh, 12 gets cancelled, nice. So -7 plus 2, so basically -5. And we plug in 1/4, which gives 3 plus 2 is 5. So you see like this is a negative values, right? So this is basically a maximum. And this is a positive value which refers to a minimum. Also I said like we also need to like find out the values of the function at the endpoints, correct? So to find out the values at the endpoints, we plug in -5 and 5. So f double dash of 5, that becomes 12 5 60 plus 262, and f double dash that.
Wouldn't you just use f of 5 and f of -5? What's the point of doing
Yeah, I
that?
was thinking that.
Yeah, that's true. Is it plot the graph?
It's always local because we're on a range.
1/4 is a minimum.
And we proved that it's 0. So we know it's not.
Can't you just tell
So we're just
us?
finding so maximum or minimum.
Yeah, that.
So I'm just
I mean, couldn't you also just,
do that.
you don't need to, the maximum and then like, those, you just substitute -7/12, 1/4, 5, and -5 all into the original function. I think that's how you do it in class. You don't need to do the double derivative.
But then how will you convent about the maxima or minima?
Whichever value is the highest is the maximum, whichever is lowest is the minimum.
But I think in the notes week we did it in a different way, yeah?
Yeah, that's how you do it now.
So notes we found out the values at the, like the double derivative values at the critical points, see? Y double dash at -1.
I meant like his notes.
Oh, his notes, okay.
Maximum, minimum.
5.
Yeah.
So just like.
So to be a max.
This could be like a local max.
Well, then we need a minimum.
What was you have against?
What kind of statements are
So
we can also max.
and what is the value of 5?
Then there has to be
The bigger one
Minus
has
5.
to be the max.
So f of 5 is a big value.
Just, yeah.
5 cube is 125 into 2 plus
275 minus
5 minus 15.
minus 25, right?
These are all like.
5, right?
This is gonna be your actual.
So for testing for local
So
max.
it's 2 times 125 is 250 plus 25 is
Or not,
275
not,
minus
but
5 is
between every two
270
70
minus
minus 10,
260.
Between every two matches. If it's continuous.
Minus 5. This remains same. This was 1. How much was this?
So it's minus
270. 275 this point. 275?
So it's minus 250 plus 25 is negative 225 plus 5 is minus 220 minus 10 is minus 230.
230.
So in this one, it's the endpoints probably that
Yeah.
will end up being the maximum and the minimum.
Minus 230, right?
Yeah.
Okay. Okay.
How did you make this ratio?
My process is still.
5 is 260.
Did you use this in the annual points?
For sure.
Oh yeah, if you do the double derivative, it's like 100%. But you can multiply, right?
In this situation, but in general, I think.
So-
Yeah.
If there's like a bunch of them.
0 is 10,
Yeah,
minus
it's
10.
easier to do that. But in my opinion, this question.
So this is how the graph will look at the end. So if we see the values, we saw like at f of 5 it's 260. So f of 5 it's 260. At f of minus 5, we just plugged in the value in the function. F of minus 5 is minus 230. So it's minus 230 at f of minus 5. And we saw at minus 7 by 12, f double dash is negative, which refers to a maxima. So we see a maxima, like a local maxima. This is a local maxima. Although the absolute maxima for the function is this one, because you see the value, let's take 260. And at 1 by 4, which is this point, we find the local minima, and we plotted that local minima. Although the absolute minima for the function will be at minus 230, at minus 5, which is the end point, which refers to minus 230. So the idea is like you have to find, like if it's a quadratic function, you have to you will find the critical points, those are the roots of the function, and also you have to find the value of the function at the end points. So for this case, you see like the end points becomes the maxima and the minima for the entire function. So if it comes in the exam, so you find out the critical points, find the single derivative, double derivative, and then find the values, and then figure out if it's a maxima or minima at those critical points, find the values at the end points, and then comment like which is the absolute maxima or the absolute minima. So these becomes like the absolute maxima, absolute minima, but these are the like local maxima and local minima. So yeah. So this is like a kind of long question. So I guess like it comes in the exam, you'll get like yeah.
So for the exam, is everything going to be able to be done by hand, or is there going to be some sort of MATLAB portion on the exams?
We can't really test you on MATLAB in the exams themselves. So the MATLAB portion will come because we'll have some in the homeworks, and then we will have a project for you to do, which will be entirely MATLAB based.
Okay.
And then on the exams, we might have some questions with we'll have written out some code, and then we'll be like, oh, what is wrong with this or something like that. So rather than having something where you actually have to write it on the computer, because that's most likely not going to, unless Dr. Molly all of a sudden really wants us to do it that way. I don't think it's really feasible for us to test you, for you to use a computer during the test and try and code something out. That doesn't really make much sense, to me at least.
So any questions on this problem? So this is a basic. You should remember this. So if it's a cubic function, there will be like so So it's the same thing. So there will be like 3 roots, and then you proceed the same way. You like check at every critical point, like 3 critical points. But we probably like won't give a cubic function because it will be difficult for you to like factorize and find the critical points. When it's a cubic function, you find the derivative, it becomes a quadratic function, and you know how to find the roots of the quadratic function using this. So yeah, if you don't have any questions, then Mahesh will go with the next question.
I think this should be the last one.
Yeah.
Okay. So we're gonna look at a different function. We're gonna do y, or actually no. We'll do f of x. F of x equals absolute value of x, and we're basically going to figure out is this continuous? And we're going to also check for differentiability at x equals 0. So I hope that we all have a general idea of what absolute value of x looks like. Basically just like that. So just graphically, it is continuous because it reaches to the same point at x equals 0 from both sides, but this like very sharp change between x being negative and x being positive means that it's not differentiable, but we're going to prove that with a little bit of math. So in order for something to be continuous, basically the limit as x approaches 0 of f of x should equal to f of x. So one way to figure out what the limit is as x approaches 0 is to check it from both sides. So limit as x approaches 0 from the right, so it's from the right of f of x. As we basically as we approach from this side, it reaches, or f of x reaches 0. We get 0. Then limit as x approaches 0 from the left. As we zoom down, we eventually reach f of x equals 0 from the left side as well. So limit as x approaches 0. And also, f of x at 0, the absolute value of 0 is just 0. So all of these correspond, so we know that it's continuous at x equals 0. Now for the slightly more difficult part, we need to check if it's differentiable at x equals 0. So limit as x approaches 0, we're going to go from one side. We're going to go from the right side first. So f of x minus f of 0 all over x minus 0. So basically, what we're going to figure out is that, so in order to figure this out, so f of x is basically the absolute value. So we'll take x as some positive number. So the absolute value of a positive number is just equal to the number itself, right? So x. So we'll say this is, we'll basically say this is equal to x minus 0 over x minus 0, which equals 1. Okay then, so for when we approach it from the other side, x 0 minus of f of x minus 0 over x minus 0. When we have a negative number, When we have a negative number, you take the opposite of that, right? So absolute value of negative 2 is just 2. So it's minus x. So then when, so then basically you can just write this as minus x minus 0 all over x minus 0, which then equals negative 1. So because these two are not equal, basically we can say that it's not differentiable at x equals 0. Does that make sense? Any questions with that? No? Okay, awesome. So this is kind of what you would have to do if you're given a similar question on the homework. We have enough, I think we have enough time. I can look at just one more thing real quick. So this will be the last thing, I think. Yeah. Yeah. So let's look at f of x equals x cubed on the interval from -1 to 1. And we want to use Rolle's theorem. To find if there is basically anywhere where f prime of x equals 0. So kind of the important thing here is that we know graphically that right here at x equals 0, f prime of x equals 0. But if we want to use Rolle's theorem, we have to say that f of 1 equals 1, and then f of minus 1 equals minus 1. So we can't really use Rolle's theorem in this case, even though we know that f prime of x equals 0 at 0. So it's important that given whatever directions you have, if it says use a particular theorem, you have to don't get too excited, even if you know that there is something in the answer or something in the graph. You don't forget to include the conditions that the theorem requires. That's basically it. That's all I got. Any questions about the class material or expectations for the class or future assignments or anything? Guessing not. How are we feeling about this class in general?
Wait, sorry, just to clarify, so what would we write for our answer for that?
Yeah, well, we just say you cannot apply Rolle's theorem.
Yeah, something like that would be fine. Yeah?
Sorry, for the absolute value question, when it's continuous or not, can you just clarify on when you're finding out the differentiability? I know that you said the rule is the absolute value of x is when it's negative, when it's approaching from the left side. Can you just clarify that part of how you got the x to be negative?
Yeah. So limit as x approaches 0 from the left of f of x minus f of 0 all over x minus 0. So let's say x is -1, right? If its absolute value of x equals absolute value of -1 equals 1, right? So anytime that x is negative, you have to multiply it by -1 in order to get the absolute value of it, which is 1, right? So, and you can also see it as, on this side it looks like -x, right? This looks like the graph of -x if you just kept on going this way. So that's why I can substitute in f of x equals -x. For f of x equals absolute value.
Yeah.
Does that make a little bit more sense?
Yeah, because you're looking at the left half.
Yes.
You're looking at the negative.
Yeah, because I'm approaching it from this side, from the left side. So even if x is -0.1, you still would multiply by -1 to get 0.1.